Hey everyone, welcome. If you're staring down the barrel of the AWS Solutions Architect exam, you know that the database questions can be really tricky. So today, we're going to do a super focused deep dive on RDS and Aurora to give you that clarity you need to absolutely ace those scenarios. And we're going to start with the single biggest mistake that costs people their certification.
And this is it's a painful truth. The exam is designed to trip you up on these subtle but absolutely critical differences. See, it's not really about memorizing a list of features, it's about knowing exactly when to use one and why you'd use it over the other. Getting this one concept wrong is genuinely one of the top reasons people walk away without a pass.
Well, that is exactly what we're here to do. We're going to break down all the core concepts. We'll shine a big, bright light on those common gotchas, and we'll arm you with the mental models you need to look at any database question and answer it with total confidence.
All right, first up, let's talk about what is basically job number one for any architect: protecting the data. Because let's be real, things will go wrong. And when they do, you need to know precisely which tool to grab from your recovery toolkit.
You know, this is the kind of stuff that gives operations managers nightmares. A single mistaken command, a slip of the finger, and poof, critical production data is just gone. So what do? This isn't some theoretical question. It's a real-world test of the architecture you designed.
Your first line of defense is what's in your toolkit. For that accidental deletion we just talked about, point-in-time recovery, or PITR, is your hero. It lets you literally rewind the database to the moment right before the disaster. Now, what if you need to hold on to data for 7 years for tax records? That's when you use manual snapshots for long-term archival. And if you just need a safe place to test a new feature with realistic data, easy. You restore a snapshot to a brand new, separate instance.
Okay, I want you to burn this number into your brain. 35. This is a classic exam trap. Automated backups in RDS, they're fantastic for short-term recovery, but they can only be kept for a maximum of 35 days. So if you see an exam question that mentions long-term archival or compliance, and automated backups is an option, it's the wrong answer. You have to use manual snapshots for that.
And here it is, the big gotcha that trips up so many people. When you restore a database, doesn't matter if it's from a snapshot or a point-in-time recovery, AWS spins up a brand new database instance. And that new instance has a totally new DNS endpoint, a new address. So if you forget to go into your application's configuration and update that connection string, your app will still be pointing at the old broken database. You have to make that change.
Okay, so we know how to recover from a disaster. But you know what's even better? Preventing problems in the first place. So let's shift gears and talk about building a secure, truly impenetrable database architecture from the get-go.
Your security toolkit is every bit as important as your recovery one. So if you're dealing with sensitive financial or medical data, you're going to be using KMS to encrypt that data at rest. If you want to avoid the bad practice of hard-coding database passwords in your Lambda functions, IAM database authentication is your best friend. And to lock the whole thing down, you stick your database in a private subnet and use security groups to make sure only your application can even talk to it.
Okay, get ready for another massive exam gotcha. Imagine this. Your company's been running an unencrypted database for a year, and now a new compliance rule comes down that says it must be encrypted. You'd think you could just go into the console and check a box, right? Flip a switch? Wrong. You cannot encrypt an existing RDS instance in place. It's a huge limitation that requires a very specific workaround.
And this is where we do what I like to call the three-step encryption dance. It's a simple, repeatable process. Step 1, you take a snapshot of your unencrypted database. Step 2, you copy that snapshot. And it's during this copy process that you finally get the option to check the encrypt box. And finally, step 3, you restore that new, now encrypted snapshot to create your new encrypted database. Just remember that dance: snapshot, copy, and encrypt, then restore.
All right, so we've nailed the RDS fundamentals. But for the exam, you also need to know all about its high-performance, super-powered cousin, Amazon Aurora. And trust me, when it comes to high availability and resilience, Aurora pretty much feels like a cheat code.
6. Just one number. If you remember only one thing about what makes Aurora so special, make it this number. It's not about the database engine itself, it's all about the storage layer underneath. Aurora doesn't store your data once or twice. It stores 6 copies of your data, and it spreads them across 3 different availability zones.
I mean, think about that. This 6-way replication is it's incredible. You can literally lose 2 entire copies of your data, and your database can still take writes without skipping a beat. The storage is also self-healing.
If a segment fails, Aurora just automatically repairs it using the other copies, and you feel zero impact. And for those really unpredictable workloads, like a flash sale, Aurora Serverless v2 can scale up and down almost instantly to meet the demand.
The difference in how you manage storage is also just massive. With a standard RDS instance, you have to pre-provision your storage size, or you have to carefully configure its auto-scaling settings. With Aurora, you just don't. You don't even think about it. The storage is completely elastic. It just grows as you need it, in 10 gig increments, all the way up to 128 terabytes. It's just one less thing you have to worry about.
Okay, theory time is over. We've got the tools in our toolkit. Now, let's put them to the test with some scenarios that could be pulled straight from the AWS exam playbook. This is where the rubber really meets the road.
Okay, first question, your turn. You've got an unencrypted database running in production. The compliance team is knocking on your door. What is the correct, most efficient way to get that database encrypted?
And if you said the three-step encryption dance, you are absolutely correct. You create a snapshot, you copy that snapshot while enabling encryption, and then you restore from that newly encrypted snapshot. It's a procedural answer, and knowing those specific steps is what they're testing for.
Next up, a classic disaster recovery question. But we're going to raise the stakes. We're not talking about a server failing or even a single data center. We're talking about an entire AWS region going offline. How do you design your database to survive that?
So the key insight here is that multi-AZ protects you from the failure of a single availability zone, a single data center, but it does not protect you from a region-wide failure. For that, you need a cross-region read replica. You keep a live copy of your database running in a completely different geographical region. If your primary region goes down, you promote that replica to become the new primary database, and you're back in business.
So look, we've covered a ton: recovery, security, the superpowers of Aurora. You have the toolkit. But here's the thing, memorizing facts is one thing. The ultimate goal is to think like an architect, to be able to look at a problem and know exactly which combination of these tools will build the most resilient, secure, and cost-effective solution. That's the real test.